Okay, find an equation of a line. So we have, if we know two pieces of information, we will know the equation of a line. We can know different things. We can know like basically two types. We can know the gradient and 1 point passing through the line. And we can know 2 points passing through the line. So if we have those two situations, we can find out the equation of a line. So that's 4 cases, but like I can reduce that to 2. If we know a gradient and a point, that's one thing. Okay, I know the gradient and I know a point passing through the line. I can find the equation of the line. Or I can have 2 points. If I know 2 points on this linear, I should be able to find the equation of the line. And we have some really special cases. So when we know the gradient and the point, if the point I know is y-intercept, okay, that the case can become really easy. If we know the gradient and y-intercept, I can directly use the formula y equals to mx plus c. M is the gradient, c is the intercept. Okay, that's really direct. And if we know the m and we know a general point, okay, a general point like not y-intercept, maybe is 3, 4. Like I know the gradient is 2. Like the general point is 3, 4, so I want to find the equation. That's another case. And if I know 2 points, that will be 2 cases as well. If I know one of the point is the y-intercept, if I know one of the point is y-intercept, I can use the gradient thing y2 minus y1 over x2 minus x1, find out the gradient of the line, and directly substitute m and c value. Because I already know c, this y-intercept means c values, and I can use 2 points to find the gradient, directly substitute that in as the gradient intercept form, so it's easy case as well. Then the harder case will be 2 general points. Okay, that will be 2 general points. So if I just know 2 points, I don't know it's y-intercept, I just know 3, 4 and 1, 2, and I want to find the equation. That would be the most difficult case. Okay, that would be the most difficult case. To say the difficulty level, I would say number 1 is the easiest one to find. Number 2 is kind of easy. Number 3 will be that. And number 4 will be 2 general points. So that's the difficulty level. Okay, so the one thing I want to emphasize here is this equation. Y minus y1 equals to m times x minus x1. So what's that for? If I know the gradient, okay, if I know the gradient and I know a point, like the line passes through a single point, I can use this equation to find the line. So let's have a look at the equation, example number 2. If the gradient of a linear is a half, okay, I know the m equals to a half. And I know the line is passing through the point 2, 1. I know my x1 equals to 2, my y1 equals to 1. I know a point that the line is passing through. And now I can directly use the formula. I can directly use this formula. This formula can be used when I know the gradient and I know a point on this line. So what is the formula? The formula is y minus y1. So y minus y1. What is y1? y1 is 1. Equals to the gradient. Gradient is a half times x minus x1. What is x1? x1 is 2. Okay, x1 is 2. So I know this. So I know y will equals to a half x minus 1 and plus 1. So y equals to a half x. Okay, I know y equals to a half x. So I can directly use this formula to find the equation in this way. Another way, like most of you may use, is you will say y equals to a half x plus c. Y equals to a half x plus c. You don't know the c value, but I know the gradient. I can write the equation in this way. And I substitute x equals to 2, y equals to 1 to work out what is the c value. So I can substitute y equals to 1, a half times x equals to 2 plus c, 1 equals to 1 plus c, and give me c equals to 0. So y equals to a half x. Okay, that's the second method what you can do. Like that's most of you will do by using a substitution to find a c value. But what I want to say here is, because those numbers are small and they are easy to deal with. That's why if you use this method, it's still like very easy to work. But if you go to year 11 next year, there will be some really complex numbers. They will have a lot of fractions, and you will use that method can reduce your calculation. Okay, can reduce your amount of your calculation. So this method is very, very important. We use that in a lot of place when we go to year 11. So I want you to learn it now. Okay, so if you really don't like it, you can still use this method to find the c-value, find the intercept, and put it back into the original equation. But I really encourage you to use that method. Okay, I teach you both ways. Okay, so have a think about example 1. Let's do the easy case now. Okay, for example 1. Okay, for example 1, I know 2 points on the graph. Okay, I know 2 points on the graph. And one of the graph is 0, 1. Okay, one of the graph is 0, 1. And I know another point is 4, 13. So your first thing to find the equation of a linear is always find gradient. Okay, if you don't know the gradient, you need to find the gradient. If you know the gradient, you can start next step. So do we know the gradient for this one? We don't know that. So we need to find gradient. So what is the gradient? Gradient is rise over run. Okay, rise over run. So what is rise over run? Basically, gradient equals to y2 minus y1 over x2 minus x1. Okay, which coordinates to be x1, y1, which coordinates to be x2, y2, it doesn't really matter. Okay, you just need to give each coordinates a name. So let's say this is x1, y1. Let's say that's x2, y2, and this is x1, y1. Okay? So I can substitute values in. So the gradient will equals to, okay, y2 is 13 minus y1 is 1 over x2 is 4 and x1 is 0. So m equals to 3. Okay, 13 minus 1 is 12. 12 divided by 4 is 3. So I know the gradient is 3. So when I know the gradient, I need to think about, do we know the y-intercept? Do we know the y-intercepts? If we know the y-intercepts, I know the gradient already. If I know the y-intercepts, I can directly pop into mx plus c. If I don't know the y-intercepts, I need to go through this equation. Y minus y1 equals to m times x minus x1. So that will be yes or no. If it's yes, I will use y equals to mx plus c. If it's no, I need to use y minus y1 equals to mx minus x1. Okay, so it's 2 cases. So find the gradient is always the first thing you need to do to find linear equations, because if you don't know gradient, you can't start anything. The second thing is, do we know the y-intercept? Okay, if we know the y-intercept, easy. We know m, we know c, we directly pop the values in. If we don't know that, we know a general point, which is not y-intercept. I use this formula to work out the equation. So in this case, I know the gradient is 3, and I know the y-intercept is 1. So I can directly have 3x plus 1. Okay, I can directly have 3x plus 1. So you can think about steps. Okay, what I should do for the first step, what I should do for the second step. Okay, what happens if there are 2 situations for the second step? Yes or no? Okay, so think about what we should do. Okay, let's have a look at example 3. For example 3, I want to find the equations of the line drawing the pair of points of -3 and 8 and 5, -2. I know 2 points. I don't know the gradient. So the first step is find the gradient. Okay, the first step is find the gradient. I can give any points as x1, y1. Okay, so I will say this is my x1, y1, and this is my x2, y2. So the gradient equals to y2 minus y1 is -2 minus 8 over x2 minus x1. So it's 5 minus -3. Okay, 5 minus -3. So the gradient equals to minus 10 over 8. Gradient is minus 5 over 4. Okay, 5 over 4. Okay, next step is think about, do we know the y-intercept? Okay, none of this point give me information about the y-intercept. So if I don't know the y-intercept, I need to use the other formula. So y minus y1, so y minus y1 equals to m x minus x1 minus negative 3. So that's y equals to minus y minus 8 equals to that x plus 3. Make y to be the subject. Y will equals to this plus minus 15 over 4 and plus 8. Okay, so plus 8, I can say that's 32 over 4. So y will equals to minus 5 over 4x plus 17 over 4. Okay, plus 17 over 4. Okay, so to find linear equations is really easy. If you exactly follow this method, you should be able to find the equation. Okay, if you may ask me, how about if I put 5 and negative 2 as x1, y1? It doesn't really matter. Which value you put x1, y1 doesn't really matter. If you change this 8 to negative 2 and you change negative 3 to 5, you will exactly get the same answer. Okay, you exactly get the same answer. If you substitute any point on this linear equation, you should be able to find the same equation. Okay, you should be able to get the same equation, unless you do some wrong calculations. Okay, unless you do some wrong calculations. So you can try to put x1 as 5 and y2 as negative 2. You should be able to get the same value. Okay, so the most important thing we learn for this exercise is this equation, y minus y1 equals to m times x minus x1. Okay, so what I want you to know is this equation. Okay, so if you understand what I'm talking about, you don't really need to worry about what we have for those 4 lines. That 4 lines just list out the general equation. You don't need to know that. You just need to understand what I'm talking about here. So find the gradient is always the first step. If you know the gradient, you directly jump to the second step. Think about, do you know the y-intercept? If you don't know the y-intercept, you need to use y minus y1 equals to m times x minus x1. If you know the y-intercept, directly substitute n values and c values. You should be able to find the equation. Okay, just 2 things needs to do. Okay, 2 things needs to be done for finding linear equations. Okay. Exercise 1G. Okay, exercise 1G. So 1G is find the length and the midpoints of a line segment. Okay, length and midpoint of a line segment. We learned that in year 9, exactly same thing. But like I want to emphasize here again, if you have 2 points on the linear, okay, you have not really on the linear. If you know 2 points, okay, on the Cartesian plane, you can find 3 things. Okay, by those 2 points, you can find 3 things. The first thing is the gradient if you connect those 2 points. Okay, the gradient of the linear. The second thing you can find is the length of those 2 points. Okay, if you connect those 2 points, you can find the length. The third thing is you can find the midpoint of those 2 points. Okay, and we have equations for each one. So to find gradient, we know that y2 minus y1 equals to over x2 minus x1. Okay, if it's finding the distance, you can see a graph here. Okay, so what this equation means, this equation is actually use Pythagoras. Okay, we use Pythagoras to find the distance. If you can see, okay, let's say the lower point here is x1, y1, and the upper point is x2, y2 there. Let's draw a dashed line. Let's say, okay, I know that's x1, I know that's x2, I know here is y1, and I know here is y2. Okay, so we're trying to find the length of this horizontal line. So the length of this horizontal line must be x2 minus x1. Okay, if you can see that, use the longer length from there to there is x2, subtract here, will give you the length here. So you have x2 minus x1 here. And if you want to know the vertical length here, so the vertical will be the upper one, subtract the lower one, you get the value in the middle. So for this length, you get y2 minus y1 here. So here is x2 minus x1. That's x2 minus x1. And there's y1 and y2. Okay, so now you want to find the hypotenuse, the length of the hypotenuse. So what is pasec? Pasec is a squared plus b squared, and you square root the whole thing. Okay, a squared plus b squared, and you square root the whole thing. Now you have this a is x2 minus x1, and the b is y2 minus y1. So therefore, this length must be square root of, okay, that's a value, a squared plus b squared, and you square root the whole thing. Okay, that's how this formula come from. Okay, that's how this formula come from. So now you know the distance between 2 points. We're using this formula. And the next one is finding the midpoints of the line segment. So you just remember that. So for example, you have x1, y1 and x2, y2. The midpoint will be add the x coordinates together and divide by 2. And add the y coordinates together and divide by 2. Okay, that's just really making sense. I want the middle point, so I add them, divide by 2, and add them, divide by 2. Okay, so that's the midpoint. Okay, so examples. I want to find the gradient distance and midpoint between those 2 points. Okay, between those 2 points. Okay, so gradient. Let's use M to represent the gradient. I'll say that's x2, y2, x1, y1. I use another way to label them. Doesn't really matter which one is x1, which one is x2. So, okay, y2 minus y1. So 8 minus negative 1 over x2 minus 3 minus 4. That gives me 9 over negative 7. 9 over negative 7. And that is negative 9 over 7. I'll put the negative outside. The next one, I'm looking for the distance. Okay, for the distance, I will be square root something. Square root of what? Okay, x2 minus x1. So negative 3 minus 4 and squared plus y2 minus y1 and you squared. Okay, you subtract those 2 coordinates and you square them, plus them, and then square root the sum. And that is 49 plus 9, 81. That's 130. Square root of 130. Square root of 130, divide that by 2. I'll use this way. So 130 divided by 2, 65. And you divide by 5, you have 13. There's nothing like I can take out from the square root. I cannot simplify the square root because the prime factor is 2, 5, and 13. Okay, I don't have like 2 repeated ones. So that is the simplest form. So it's square root 130. And the last one is to find the midpoint. So midpoint. Okay, so midpoint, what's the x coordinates? Is you add 2 values and you over 2. Okay, add x and x. Okay, do not add x and y. Okay, do not add x and y. Is you add x and x. and you add y and y, so it's 8 and -1 and over 2. And that gives you a half and 7 over 2. So the middle point will be a half and 7 over 2. That's the coordinates of the midpoint. Okay. For example 2. Okay, for example 2. Find the value of A if the distance between 2A and 49 is √5. Okay, I give you 2 points, but that value is missing, and I know the length between that is square root 5. Okay, the square root 5. So distance equals to square root 5. Let's represent the distance out. So what is the distance? The distance is square root of, subtract the A values, let's use 4 minus 2 squared plus, okay, so I say that's x2, that's y2, and I use 9 minus A squared, and that equals to square root 5. So what I can do is I can square both sides. I can square both sides. So what I have is 4 minus 2 squared plus 9 minus A squared will equals to 5. Okay, so square root something equals to square root 5. So the thing inside needs to be 5. And 4 plus 9 minus A squared equals to 5. So I have 9 minus A squared equals to 1. Subtract 4 from both sides. Okay, subtract 1 from both sides. Okay. Okay, now my question is, what 9 minus A equals to? What 9 minus A equals to? Something squared equals to 1. What that thing should be? 1 or -1. Okay, I should have 2 solutions. Something squared equals to a number. So the thing I want to say here is, if you have x squared equals to A, your x will equals to plus minus of root A. Okay, so I can have positive of that value squared and negative of that value squared. They will give you the same number because the negative sign will disappear after you square it. So positive and negative will give you the same value. So -1 squared will give you 1 and 1 squared will give you 1. Okay, so x squared equals to A. Your x needs to be plus minus square root A. So now I can treat 9 minus A as like the capital A. So 9 minus A will equals to plus minus of square root 1. Okay. So square root 1 is basically just 1. So I have 2 equations now. I will have 9 minus A equals to positive A, or 9 minus A equals to negative A. So my A will equals to 8 in this case, and this A will equals to 10 in this case. So I will solve out 2 solutions for this question, not only 1. Okay, most of you only give me 1 solution, which is A equals to 8. But actually I should have 2 solutions. Okay, I should have 2 solutions. If I can draw this on this line. Okay. Let's draw this. So I have 1 point is 4, 9. I'm explaining why there should be two solutions. Okay, I have 4, 9 here. And I have another points 2 and A. So here is 2. Okay, here is 2. I don't know where is A. So A can be lies on this line. Okay, A should be on this green line. Right? A should be on this green line with X coordinates 2 and I don't know the Y coordinates. So A can be on this line. Okay, so I want a value which is give me square root 5 of this distance. Okay, square root 5 of this distance. I can have two distance. I can have here will give me square root 5, or I can go to the bottom. That will give me square root 5 as well. Okay, I can go upper one, and I can go below. This is the value 210, and this is the value 28. Okay, they both will give me a square root 5. Okay, I can go connect up. This line can point in that way or point in that way. So for those two values, I can get both square root 5 of this length. That's why you should have two solutions. You should have two solutions. You won't find a third one. You won't find a third one. This is like equilateral, not equilateral, the isosceles triangle with those two angles equals. Okay, with those two angles equals and those two lines equal. If you can see here, that would be easier. Okay, so very important thing here you need to memorize is this x squared equals to a, x equals to plus minus root a, because I still see a lot of year 12 students cannot see the negative sign of that. Like they know this equation, but like they will forget all the time. So when you see squares, you need to question yourself, should I have the plus minus of that? Okay, should I have plus minus of that? Okay, number 3. Find the value of x1 and y2. Okay, x1 and y2. If the midpoint of the line segment drawing the x1 negative 1 and minus 4 y2 is 1 and 3. So 1 and 3 is the midpoint. Okay, 1 and 3 is the midpoint. So I know my midpoint is 1 and 3. So I have 2 points. I have x1 minus 1 and I have minus 4 and y2. So the midpoint between them should be you plus the x values, divide that by 2, comma, you add the y values and divide that by 2. Okay, that should actually be the midpoint in terms of x1 and y2. And if you can simplify that, that's x1 minus 4 over 2 and y2 minus 1 over 2. And now you know that the point should be 1, 3. You know that point is actually 1, 3. So what you know here is x1 minus 4 over 2 will equals to 1 and y2 minus 1 over 2 equals to 3. And you can solve out the x1 equals to 2 plus 4 equals to 6. And then y2 equals to 7. Okay, y2 equals to 7. You can use this to set up an equation, a linear equation, and you're trying to solve for x1 and y1. Okay, trying to solve for x1 and y1. That's page 11. Okay, so I'm not going to continue today, but I want you now to do page 14. Okay, I want you to do page 14 now.